Okay, part 6 of the test review. So, without a calculator, we want to simplify these. All right, number 1, 9 to the 1/2 power. All right, so 1/2, right, a quick review. What does this mean? That the top number in the exponent of the fraction is the power, and then the bottom number is the root, right? Because roots grow underground. Well, it's given that 1/2 is the square root. So the square root of 9 is basically 3. Right, but let's just say it wasn't 2. If it was something else, like, for instance, on number 4, how the bottom root is a 4th root, right? It's not a square root. All right. Number 2, we want the third root of 125, meaning something times something times something 3 times. And in this case, it's going to be 5, right? Because 5 times 5 times 5, in fact, it's going to be -5, right? Because there's a negative and it's an odd number root. So the cubed root of -125 is -5. Basically, because -5 times -5 times -5 is -125, right? A negative times a negative times a negative. So just remember that even number roots can't have negatives. Odd number roots, you can. It just depends on the situation. Okay. So here, there's a difference between 2 and 3. Right. It's not that it's on accident or that there's a typo. Right here, in number 2, the negative is definitely inside the parentheses, so the exponent's going to apply to the negative. Number 3, there are no parentheses, so the 1/3's only going to apply to the 8. So this is like -1 times the cubed root of 8, right? This is root. So again, something times something times something needs to equal 8. In this case, it's going to be 2. Right? And it needs to equal +8, not -8, because again, the negative is not attached to the 8 like it was in the previous problem. So this is going to be basically -1 times the cubed root of 8, which is 2. So this is going to be -2. Hope you can see the difference between the two. Okay, number 4, the cube root of 125. So this is like the last problem, just positive. Again, cubed root. So you're taking 3 things and you're multiplying it to make 125. Well, it's going to be 5. Right, cubed root of 125 is 5. Fourth root of 16. Right now we have 4 things being multiplied to make 16. I have a feeling it's going to be 2. Right, 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, it's 2. Keeping the same pattern. The root is 2, so square root of 36. This means 2 things being multiplied has to equal 36. It's going to be x equals 6, right? The square root of 36 is 6. All right, 7. 8 to the 0 power. Anything to the 0 power. Anything to the 0 power is always 1. All right, number 8. We have the power is 2 and the root is 3. So we can either square 8 and then take the cubed root, which isn't bad, or we can take the cube root of 8 and then square it. That way's not bad either. I think taking the cube root of 8 and then squaring it is better, because the cubed root of 8, right, this means that something times something times something is equal to 8. Well, we know that it's 2. The cube root of 8 is 2. And then 2 squared is going to be 4. So we took the root first. Then power. So take the root first and then the power. Now, again, do we have to do it that way? No. We could have squared 8, which would have been 64. Then the cube root of 64, that is a nice number. But what if it wasn't a nice number? What if it was like the cube root of, like, I don't know, like something crazy, 2,596? Like, how would you take the cube root of that? So without a calculator. So I think taking the cube root first while it's small and then applying the power is better. But you do you. Again, right here, point in case. If we take 8 times 8 times 8 times 8 times 8 like 5 times, it's going to be a really big number to take a cube root of that. So I think if we take the cube root of 8 first, the cube root of 8, which is 2, and then we apply the power, right? Because the root and then the power. So if we apply the power now, doing 2 5 times, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Is better. Especially right here. Especially right here. So the 4th root of 81. 4 things being multiplied that make 81. Might be 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So it's definitely 3. That's the 4th root part. And now we apply the power. So 3 times 3 is 9, times 3 is 27. Okay, they get tougher. 64 7/3 times 64 negative 6 over 3. Okay. When you multiply common bases, you add the exponents, right? These are the bases. The bases match, so we can essentially add the exponents. So 7/3 plus negative 6/3, they got the common denominator already. So 7 plus negative 6, which is going to be 1, positive 1. So 64 1/3. So 64 to the 1/3 power. So the cube root of 64 is what this is saying. So 3 things being multiplied that make 64. I feel like it's 4. 4 times 4 is 16, times 4 is 64. So it's going to be 4. Okay, number 12 is our first encounter with the negative exponent that's a fraction. So a couple of different ways of doing this. It really doesn't matter how you do it. I think that getting rid of the negative first, maybe, or you could get rid of it last. It truly doesn't matter. But 2 is the root, 3 is the power. So if we took the square root first, square root of 9 is 3. And then 3 cubed is going to be 3 times 3 is 9, times 3 is 27. But then it was a negative exponent, which means we're going to push that number down into the denominator. So 1 over 27. right? So we did the root first, the power, just like normal. The only difference is now there's a negative in the end. Now, could we have done the negative first? Sure. Then it would have been 1 over 9. And then that would have been, the 9 would have been to the 3/2 power, right? 1 over 9 to the 3/2 power. And then you would have done this exact same thing to find out that it would have been 27 in the bottom. So I think handling the fraction first, like in the first 11 examples, and then just doing the negative at the end, pushing it down to the denominator, I think that's ideal. Okay. Let's try number 13. So again, we have a fraction, 8 over 27, can't be reduced. Top number is even, bottom number is odd. And we have a negative 1/3 fraction. So if we do what I just said, apply the fraction, the root to the top and the bottom number, and then the negative, we can flip it. Or we can flip it first and then take the cubed root of each number. In this situation, it does matter. Like it's always situational, right? Every situation is different. So if we take the cubed root of 8 and the cube root of 27, this would be, cube root of 8 is going to be 2. Cube root of 27 is 3. And then this is all to the negative 1 power, which means we're going to reciprocate and make 3 over 2. Okay. 16 to the 1/2 power. So square root of 16 is 4. All right, 15. Again, 9 over 5. Those are perfect squares, by the way. And then we have to the negative 3/2 power. So square root cubed. And it's negative. So what did we do in the last one? So in the last one, we took the cube root and then we flipped it. Truly doesn't matter what we do. We could take the square root of both these numbers and then cube them and then flip them. Or we could just flip them now, then take the square root and then cube it. Truly doesn't matter. So if we flip it first, this is going to be 25 over 9 to the 2/3 power. Oh, man. To the 3/2 power, right? Because we got rid of the negative. We flipped just the inside part. Never flipped the exponent like I just tried to do. And then take the square root of the top and the bottom. So square root of 25 is 5. Square root of 9 is 3. And this is all being cubed. Right, every time you do the operation, like it kind of went away, right? Like the 2 is no longer there because we've already taken the square root. If we cube the top and cube the bottom, so 5 times 5 is 25, times 5 is 125. And then 3 times 3 is 9, times 3 is 27. No, that went quick, but it should be quick. Like these should be very, very quick. And then number 16, 9 to the 3/2 power. Again, this is the cube power, and then this is the square root. So square root of 9 is 3. And then cubed will be 81. I'm lying. 3 times 3 is 9, times 3 is 27. All right. So is there more? Yeah, there's more. Okay. All right. 17. Okay. I have a feeling. No, I don't have that feeling. 7, 8, 9. No, 117. Is 117 a perfect square? Okay, it's not. 13 is a prime number, so I know you can't take a square root of that. 117 might be a prime number also. Yeah, it is. Oh, no, wait. 117 is divisible by 3. Okay, so let's see. What do I want to do? What do I want to do? Can't take the square root. Can we cube it and then make a square root and then take the square root? Is it calculator portion? No, it's still a non-calculator part. $117 is not a prime number. Let's see if it can be divided by 13. I have a feeling it will. What's 13 times 9? Hey, okay. So this whole thing becomes 9. What was the last problem? 9 and 3. All right, so we know this answer. We know this answer. 9 to the 3 halves is 27. Dang. They almost got us. They almost got us. Again, common basis, 18. Adding common basis, we add the exponents. So this is going to be 28 to the 1/3. Can 28 be rewritten? Let's see. No, I don't think it can. I don't think it can. All right, so when we add the exponents, we got to make sure that you have a common denominator. So common denominator is going to be 7/2 plus -6/3. All right, so the fastest way to a common denominator is by multiplying by the other denominator. Right, the other denominator is 3. So top and bottom times 3. All right, 3/3 is just 1. On the right-hand side, 2/2. So this is going to be 21/6 minus 12/6, right? 6 times 2 is 12. And this is going to be 9/6 positive, which is basically 3/2. So this is our power, or our exponent. So 28 3/2. Bro, is it 3? Oh yeah, it is. 3 goes into 9, 3. 3 goes into 6 twice. All right, so square root of 28. There's no square root of 28. Okay, and 28 can't be reduced anymore. However, right, I'm not letting this stop me. So we're saying, what are we saying? Square root of 28 3 times. Right, this is what it means for the 3/2 power. Right, we're taking the square root 3 times. Well, this is going to be, right, 28 times 28. Root 28 times root 28 is just 28. And then the square root of 28. Can this be simplified? And this problem's intense. So this is going to be 2 times 14, which is 2 times 7. We can bring out a pair. Right, bring out a 2. When the 2 comes out, it's going to multiply times the 28. So 28 times 2 is what I'm saying. What's 28 times 2? 48 plus 8 is 56. 56 root 7. That is crazy. I don't even know if that's the answer. We need to look at a key somewhere. But if I had to bet on it, that's what I would bet. Because there's no way they want you to leave it like 28 3 over 2. I mean, is it? I mean, I don't know. But I definitely simplified it. I simplified it down to 56 root 7. That's something, I guess. So if you can get a key, let me know. All right. Number 19, 27, 2/3 power. So 2 is the power, 3 is the root. 3 times 3 times 3. So cube root of 27 is 3, right? Because 3 times 3 is 9 times 3 is 27. Squared is going to be 9. All right. So solving for x without using a calculator. Solving for x. When you multiply common bases, you add the exponents. So 3, 2x plus 4 is equal to 3, 5x minus 11. Now, because the bases match, we don't care about the bases any longer. So 2x plus 4 is equal to 5x minus 11. Right, when the bases match, 3 to something is equal to 3 to something else. Therefore, the something and the something else must match. Right, that's why we can say that we don't care about the bases, because the exponents must match because they're equal to each other. So this is going to be at 11 minus 2x. So 15 is equal to 3x. Divide both sides by 3. X is equal to 5. Okay, 21. So there's a couple of different ways of doing this. When you have division, right? When you have multiplication, when you multiply, you add the exponents. Therefore, when you're dividing, we subtract the exponents, right? Top minus the bottom. So you could say that m to the 2x plus 3 minus 5, right? Minus the bottom is equal to m20. Right, top minus the bottom, because the bases match. So this is going to be 2x minus 2 is equal to m20. Again, the exponents, the bases match, so we can set the exponents equal to each other. Add 2. So 2x is equal to 22. Divide both sides by 2. X is equal to 11. All right, the last non-calculator part. Okay, we got a lot of things going on here. First off, power raised to a power, you multiply. So 7, 12x. Times 7 to the 6. And here we have top minus bottom because the bases match, right? Top minus bottom. Okay, left-hand side, multiply common bases, you add the exponents. So 7, 12x plus 6 is equal to 7, 2 minus 2x. All right, we got them down to single bases, so we can set the exponents equal to each other. All right, I'm going to add 2x. I'm going to minus 6. So we're going to get 14x is equal to negative 4. Divide both sides by 14. So x is equal to negative 4 over 14, which is basically x is equal to negative 2 over 7. All right,